Welcome to part 3 in my Operations with Complex Numbers video series. In this video, we're going to talk about evaluating powers of I and dividing complex numbers. We hopefully by this point know that I is the square root of -1. And from the last video, we know that I squared is -1. But what about higher powers of I? What about I? That's a terrible looking I, sorry. What about I to the third power? Well, I to the third power is I times I squared. Because this is I to the first times I to the second. So that would just be I times -1 or -I. What about I to the fourth? I to the fourth could be rewritten as I squared times I squared. And we know I squared is -1, so I have -1 times -1, which is a positive 1. And this is a pattern that will always repeat. I to the fifth will be the square root of -1. I to the sixth will be -1. I to the seventh will be -I. And I to the eighth will be positive 1. And it's going to keep going like that until the end of time. So what we can do is use little tricks like how we figured out I to the third and I to the fourth to figure out larger powers of I. So let's say I have I to the 12th. I to the 12th is the same thing as I squared to the sixth power. I squared is -1 to the sixth power, and any negative number to a even power is going to become even. So I to the 12th really is just 1. What about having I to the 25th? Well, I to the 25th is the same thing as I times I to the 24th. I to the 24th is the same thing as I times I squared to the 12th power. So what do we have here? This is going to be I times -1 to the 12th. -1 to the 12th is a positive 1. So I really just have I times 1, which is I. And that's how we can figure out any power of I. Now there is another way that we can think of it, and I'll show you that right now. One other way to do this is, if you think of I squared, I to the third, and I to the fourth, which, as we hopefully remember, I to the first is just I, or the square root of -1. I squared is -1. I to the third is -I. And I to the fourth is positive 1. There are 4 pieces to this pattern. So I would think of these decimals, or think of these as decimals. 0.25, 0.5, 0.75, and 0. Now, why do I want that? Let's say I had that I to the 25th again. Another way I can figure out the value of I to the 25th is to take 25 and divide it by 4. 4 because of the 4 pieces in our pattern. 25 divided by 4 is 6.25. Now, I don't care about the 6. This 6 over here means nothing to me. What I care about is the decimal. 0.25 matches the 0.25 here. So I to the 25th, as we discovered, is really just I. If I had a number like, let's say, 2,000 I to the 2003 power. I can take 2003 and divide it by 4, which would give us 500.75. Once again, I don't care about the 500, I care about the 0.75, which matches up with negative I. So I to the 2003 is really the same thing as negative I. And that's just another way that you can figure out the different powers of I. Now let's talk about dividing complex numbers. Here we have the complex number 3 plus 7i, and we are dividing it by 8i. You cannot divide by imaginary numbers. So in order to actually do this division, what we need to do is multiply the top and the bottom by the conjugate of the denominator. So the denominator is 8i, meaning the conjugate is negative 8i. When we multiply these out, on top we get negative 24i minus 56i squared all over negative 64i squared. Now we have to take care of our I squared terms, which become negative 1s. So instead of a negative 56, I now have a 56 minus 24i all over 64. And lastly, 56, 24, and 64 can all be divided by 8. So this will turn out to be 7 minus 3i all over 8. And that is our final answer. The only other thing we could do with it is break it up to be 7/8 minus 3i over 8. And we have successfully divided with complex numbers. But what if, instead of just being an imaginary denominator, what if we have a complex number in the denominator as well? Well, let's take a look and try an example like that. Here we have 5 plus I being divided by 2 minus 4i. Just like before, we are dividing in the bottom by something that has an imaginary number, so we are going to have to multiply the top and bottom by the conjugate of the denominator, which is 2 plus 4i. Well, since we are multiplying a complex by a complex, we're going to have to distribute. We're going to have to FOIL it out. So I have 5 times 2, which is 10. 5 times 4i, which is 20i. I times 2, which is 2i. And then I times 4i, which is 4i squared on the top. On the bottom, we get 4. 2 times 2 is 4. Plus 2 times 4i, which is 8i. Negative 4i times 2 is a negative 8i. And negative 4i times 4i is a negative 16i squared. And I just realized I made a mistake. This should have been a plus 4i squared on the top. Now, take care of our I squared terms and combine any like terms that we have. 4i squared is a negative 4. So 10 with a negative 4 is going to be 6. 20i plus 2i is 22i. So our numerator is 6 plus 22i. Negative 16i squared is a positive 16. Plus 4 is 20. And 8i minus 8i is 0. So we have 6 plus 22i all over 20. And 6, 22, and 20 can all be divided by 2. So our final answer is going to be 3 plus 11i all over 10, or 3/10 plus 11i over 10. And there we have it. Hopefully you found these videos on operations with complex numbers useful. Good luck dealing with complex number operations.